Hi, it's Chris Chinnock here for Display Central. I'm in SID 2013. I'm with Chris. What was your last name again?
Hudson.
Hudson, of course. And what's your product title?
I am the commercial director for a Corning business called High Performance Displays, which focuses on the glass substrates that go into Oxide, TFT backplane devices, as well as LTPS backplane devices.
Okay, so at SID this year, you're announcing basically the next generation of Lotus XT, which is the high-performance glass substrate which you've been working on, and this is specifically aimed at low-temperature poly applications and oxide, correct?
That's correct. And we launched our first Lotus family product in October 2011, which was designed at the high-performance display, LTPS. At that point, we were focusing on in working with Samsung. This product is designed to suit the requirements of both LTPS and Oxide backplanes in any application in the industry right now.
Now, those two processes can potentially have different requirements in terms of the glass stability and pitch, but what you've tried to do is optimize something that works basically for both processes, correct?
That's right. I mean, those processes and all processes are all a little bit different and unique in what their temperature profile looks like. So glass will perform differently in each customer's process. In an oxide process, may go to an intermediate temperature, something plus or minus 400 degrees C, but it might be held at that temperature for a long period of time. Where in LTPS, you might go to temperatures significantly higher than that, in certain cases above 600 degrees C. But the common factor in both cases is you want to minimize how much that glass moves, but more importantly, how much you control the variation of that movement on a sheet-to-sheet basis. So that is common no matter which of those products you look at. What we designed Lotus XT for was to minimize that variation, or what we call total pitch variation, when it runs through a customer's process, whether that variation is within one sheet of glass or the variation as you go from one sheet to another sheet.
Okay. And it has to be, I guess, controllable or repeatable, I guess, is the key thing, so they can adjust the process for a repeatable fabrication. Right?
That's correct. I mean, these processes are used for some of the most advanced devices today. So you're looking at smaller transistors, trying to pack more pixels in on every inch of a display. And when you do that, your tolerances for how much that glass can move or how much that variation can move, it's reduced dramatically. So you can imagine if you're trying to take one piece of glass that is moved and align it with another. And in an LTPS process, you might be using a color filter on that. If you can't predict that variability sheet to sheet, you're going to get misalignment. And that either lowers yield, or in worst cases, it reduces our customers' ability to go to their next generation of devices, which could be 400 or 500 pixels per inch.
And that seems obviously is the trend now with smartphones and tablets, but you're starting to see some potential take-up of this in ultrabooks and laptops also. Is that correct?
That's right. We saw the first, what we would call an HBD or an HBD backplane supported device in the market last year, where you had tablets actually in the market in 2012 that use an Oxide device. You're seeing that same trend carry forward now, but you're also seeing in ultrabook or high-resolution notebooks a desire for a device that not only goes to higher resolution, but has enhanced power savings features as well. And that's one of the things that we see Oxide manufacturers touting as one of their value propositions. So as that segment grows, we expect the glass requirements to grow with it.
Now you have a joint venture with Samsung, so we're going to see some Samsung displays, but you're also announcing some new customers here. Tianma, for example, tell us about this.
That's right. So I mean, we're happy to announce that yesterday, or the first day of the show here, we jointly announced with Tianma the qualification of Lotus XT in their LTPS LCD process, which is a Gen 5.5 process, and will ramp up through the second half of the year. We've been working with them very closely in amorphous silicon and now also into the LTPS space, and they see the same value in our product or really the best in industry performance when it comes to total pitch variation. There's obviously a number of other customers that we work with as well, but we've shown Tianma here today due to the joint press release. We also work very close and collaboratively with the Century, which is a part of the Foxconn group, and we're also showing some of their panels here as well. They've been using Lotus glass as far back as our first generation product to support their LTPS business as well.
Okay. And we should see more product in the market the second half of this year?
That's right. That's right.
Great. Thank you, Chris.
Thanks, Chris.
Chris Chinnock for Display Central.